Okay, we're going to start section 5.4 notes over dividing polynomials. Part 1 is just going to focus on long division. Okay, let's go ahead and practice or review long division. We're going to divide 452 by 2. The number that is being divided is called your dividend. The number that is doing the division, in this case it's our 2, that is called our divisor. And the value that results is called our answer or our quotient. Alright, so when I start with division, I want to see how many times does my divisor, 2, go into 4. 2 goes into 4 evenly 2 times. Then I take 2 times 2 and I get 4. You always do subtraction. 4 minus 4 is 0, but you do not have to write down 0. Instead, if it's 0, go ahead and just drop down your next term. So I have 5. Well then how many times does my divisor, 2, go into 5? Evenly. And that's also 2. So then I take 2 times 2, I get 4. You always do subtraction. 5 minus 4 is 1. And then I go and I drop down my next term. So how many times does 2 go into 12? And that's 6. So I take 6 times 2, my divisor, and I get 12. I'm going to subtract them, and we have 0. So in this case, 452 divided by 2 is 226. So if the book asks for my quotient, you need to write down 226. If they ask for the remainder, it would be 0. If you wanted to check that your quotient was right, of course we know that we could multiply 226 times our divisor of 2, and that should give us our dividend, which was 452. So we are correct. Okay, now we're going to review how to factor. We have x squared plus 7x plus 10. Well, when you factor a trinomial, you know you're going to end up with a binomial pair. Well, what times x squared gives you x squared? It's got to be x and x. Now I want to find factors of 10 that add to 7. Well, those could be 1 times 10, or 2 times 5, and that's it. In this case, to get 7, my only possible combination would be 2 and 5. I want a positive 10 and a positive 7, so this will be x plus 2 times the quantity x plus 5. Now remember, not all quadratics will factor though. Okay, now we're going to practice long division with polynomials. The problem says to use long division to divide 3x squared minus 29x plus 56 by x minus 7. And the polynomial that I have circled is my dividend. X minus 7 is my divisor. So I write x minus 7 on the outside, and then I'm going to write my dividend underneath. But you want to make sure that the dividend is in standard form, and you have no missing terms. This is an x squared, an x, and then my constant. Now we do the same process that we did when we just had numbers without variables. And I look, how many times does x go into 3x squared? Or you can think of it as what times x gives me 3x squared. And that's going to be a 3x. I wrote the 3x above the 29x because I want to keep my like terms in the same vertical column. So I take 3x then times x, and we get 3x squared. 3x times negative 7 is minus 21x. Now I'm going to do subtraction, but when you subtract a quantity, it's really the same thing as distributing each term by negative 1. So this positive 3x squared becomes negative, and the negative 21x is going to become positive. And then I work vertically. 3x squared minus 3x squared is 0. You don't have to write that. Negative 29x plus 21x is negative 8x. And then you drop your next term. And we have 56. I'm going to go ahead and disregard the 0, and I will look how many times does x go into negative 8x? Or think what times x will give me a negative 8x. That's going to be a negative 8. So I take negative 8 times x, and negative 8 times negative 8 times negative 7 is positive 56. And I want to subtract again. But subtracting is the same thing as multiplying each of these terms by negative 1. So that's going to become positive. And this 56 here is going to become negative 56. So negative 8x plus 8x is 0. Positive 56 plus a negative 56 is 0. And my quotient is then 3x minus 8. My remainder is 0, which means x minus 7 divides 3x squared minus 29x plus 56 evenly. Okay, now we're going to do another long division problem. This one is not in your notes. It says to go ahead and divide 3x to the 4th minus 4x cubed plus 12x squared plus 5 by x squared plus 1. So the x squared plus 1 is my divisor. And the 3x to the 4th minus 4x cubed plus 12x squared. Now I do have to write plus 0x plus 5. I need that 0x because it's my placeholder. If I am missing any terms, you have to put them in with 0. For instance, I have an x to the 4th, x cubed, x to the squared, and then I need to have an x to the 1st, and then my constant term. So I put in 0x. All right. What times x squared gives me 3x to the 4th? And that is going to be a 3x squared. Now remember, we want to keep our like terms in the same column. So I write 3x squared above the 12x squared. Then I have 3x squared times x squared is 3x to the 4th. 3x squared times 1 is 3x squared. And I subtract. But when I subtract a quantity, you need to distribute each term inside the quantity by negative 1. So the 3x to the 4th becomes negative, and the 3x squared is going to become negative as well. So these two add up to 0. I have 12x squared plus a negative 3x squared, or you can simply think of it as 12x squared minus 3x squared, and you get 9x squared. And then everybody knows that we need to drop our next term. But at the same time, I also need to go back and drop this term, the negative 4x cubed. If I haven't used it yet, if there are any before the 9x squared, you still need to drop those terms. Now, how many times does x squared go into negative 4x cubed? And that would be a negative 4x. So now I'm going to take negative 4x times x squared and negative 4x times 1, and I get negative 4x. Now I still want to do subtraction, but that means that I multiply negative 4x cubed by negative 1, basically, and this by negative 1. It's going to change both of those to positive. So these will go to 0. 0x plus 4x now becomes 4x, and I drop my next term. But I also need to drop this term because it's written before and I haven't used it. Alright, what times x squared will give me 9x squared? And I know what you're thinking, it's 9. So I take 9 times x squared and 9 times 1. Now I'm running out of room here. When I subtract, the 9x squared becomes negative, and this 9 becomes negative as well. So 5 plus negative 9, or think of it as 5 minus 9, is going to be negative 4. And I have no more terms on the outside to drop, but I do need to drop this 4x. Alright, so my quotient is going to be 3x squared minus 4x plus 9, but I also have a remainder. So one way to write that, and I'm going to just write this sideways, as I could rewrite it as 3x squared minus 4x plus 9 with a remainder of 4x minus 4. Now I really don't want you to write your answers like that. We always did that in elementary school, but we're not in elementary school anymore. So you would write your final answer as 3x squared minus 4x plus 9 plus your remainder over your divisor. And that is the quotient. Okay, so this is the last example for Part 1 notes. Now we're going to check to see if x to the fourth minus 1 is a factor of p of x. And in order to see if something is a factor, I need to know that it divides it evenly. Think about factors. If I ask for factors of 10, you would tell me 1 and 10, because 1 times 10 is 10, or 2 and 5. 2 times 5 is 10 as well. So those are 4 factors of 10, 2 pairs. In order to check to see if I have factors here, I'm looking for, is the remainder going to be 0? If it is 0, then yes, x to the fourth minus 1 is a factor. So I'm going to need to check with division. Before I can write in my dividend, I want to make sure I have all of my terms. I have an x to the fifth, an x to the fourth. I'm missing an x cubed, so I'm going to have to fill that in with 0. And I'm missing an x squared, so I'm going to have to write 0x squared as well. Then I have my x to the first and my constant. So I'm just going to rewrite this now. X to the fifth plus 5x to the fourth plus 0x cubed plus 0x squared minus x minus 5. Alright, this will not take as long as what it looks like it will. What times x to the fourth gives me x to the fifth? And it's x. So I write it above my x. Then you need to take x times x to the fourth and x times negative 1, which is just negative x. I'm going to subtract, which means basically I'm going to multiply each of these terms by negative 1, change the signs on them. Then I have x to the fifth minus x to the fifth is 0. Negative x plus x is also 0. You still bring down your next term. But I also need to bring down all of these. I have not used them yet. So this is really 5x to the fourth plus 0x cubed plus 0x squared minus 5. All right. What times x to the fourth gives me 5x to the fourth? And you're probably thinking, it's a 5. So now I'm going to take 5 times x to the fourth and 5 times negative 1. I want to do subtraction again. This becomes negative and this becomes positive. 5x to the fourth minus 5x to the fourth is 0. Negative 5 plus 5 is also 0. I have no more terms after the negative 5 to bring down, but I still need to bring down my 0x cubed and my 0x squared. In this case, anything times 0 is 0, so I don't have to worry about these two leftover terms because their coefficients are 0. Which means that my remainder is 0. So I could say that yes, x to the fourth is a factor because I ended up with a remainder of 0. It says if it is, you want to write p of x as a product of two terms. What that means is what times my divisor will give me p of x. That's your quotient, x plus 5. So if I really wanted to check my long division, I could multiply or FOIL x to the fourth minus 1 times x plus 5, and I should end up with my p of x. Now this last slide over the factor theorem, we will save that for notes tomorrow and we'll discuss it then. Make sure that when you come to class tomorrow you have your notes filled out and you should have at least one question ready to go to ask me that you had over this lesson.